Well guys, after reading this problem, first impression, you probably had the same impression that I did, and that is that they gave this advertisement, which was probably one of the least effective advertisements you've ever seen in your life. And I think this, first of all, for two reasons, and maybe you're thinking the same thing that I am, but the fact that they leave it for the consumer or the potential consumer to have to do the math in their head. And nobody really wants to deal with very, very large, unattractive numbers. And the second part of this is the fact that they gave you numbers. They gave you exact data. I mean, God, they're being nice, aren't they? But the thing is, they gave it to you in English. They wrote it out in words, as opposed to giving you numerals, the 3,714 and the 4,952 dentists total. So basically, here's what they tell you. They say, 3,714 dentists recommend that you chew our gum out of a total of this is how many we asked. Now, I know that you notice, just like I do, that the majority of the dentists said that they recommend this gum. And what I know is that this is about 5,000 and this is about 3,800. And that's clearly more than half of 5,000-ish, which would be 2,500. So it's looking good for this gum company. I want people to buy my gum. But here's the thing. I want to write an advertisement that is much more effective than the one that I've already got on this piece of paper. So how am I going to do this? Let's take a look over here. But these are the different tools that we have in our toolbox thus far that we've been working with in class. We could use a fraction to help us represent our data to make this a little bit more effective. We could actually use a percent, a ratio, a difference, and scale factor. Now, I know we've been talking about this in class a lot over which ones would be most effective and which ones would not be very effective. Starting with the ineffective, but probably overall I'd say the most ineffective is the difference. And the reason why is because it doesn't give us any scope of how many people we asked to begin with. I could say, 20 more people said they liked school lunch that didn't like school lunch. Okay, but then the question is, well, how many people did you ask in the first place? If I asked 300 people, that's really not a whole lot. If I asked 20 people, well, then 100% of the people said that they liked school lunch. So within this context, we could use a difference between what and what. Well, we could say, well, this many more dentists recommend chewing this gum than didn't. Two things. One, you have not been given a table. When you have a problem like this, number one thing you're going to want to do to help us see the information better, is to make a table. And two, they did not tell you how many dentists did not actually recommend that we chew this gum. Doesn't mean that they don't prefer it, just means that they didn't recommend it. So here's what we'll do first. We'll actually fill this part out so that we can maybe come up with an advertisement that would compare how many dentists recommended it to how many dentists did not recommend it. So here's what we'll do. We'll find this difference between 49.52 and 37.14. So we say 4,952, 3,714. Okay, subtracting, we do have to borrow from the 5, making it a 4, but 12 minus 4, of course, is 8. 4 minus 1 is 3, 9 minus 7 is 2, and 4 minus 3 is 1. We have to ask ourselves, what is this number right here? And remember, this number is the difference between the total and how many recommended. So what this actually represents is the number of dentists that did not necessarily recommend that we chew this gum. Okay, now that I have these different things, if I'm a gum company, I want people to buy my gum. I want to show that more dentists recommended that did not recommend, and I want this to be very, very effective. Now, like I said, people like small numbers, and they want you to be honest with them. But using a difference comparison, maybe we could actually state how many more dentists recommended than didn't recommend. Well, how many more dentists did recommend than didn't? We're going to have to find this difference. I'm starting with the weakest comparison. Okay, so we say, all right, the difference between this, which was the number that recommended, and the number that did not recommend, subtracting, we say, okay, got to borrow, make this a 0. 14 minus 8 is 6. We do need to borrow from the 7, making it a 6. So now we have 10 minus 3 is 7. 6 minus 2 is 4, and 3 minus 1 is 2. So here's what we can rightfully say. 2,476 more dentists recommended that we chew this company's gum than those that didn't. Like I've already mentioned, this is a very large difference. But of course the audience is going to want to know, well, how many people did you ask? You're not giving them the whole picture. You're telling the truth, but you're slightly misrepresenting it. So here's what we're going to say. This is a comparison you could use, but would you agree with me, and I hope you would, that this is an extremely ineffective comparison that we could use to help sell our gum. So we say, okay, difference, we've done a difference, but it's not very effective. What could we do that would be very, very effective to show that a lot of people prefer to chew our gum? Well, let's think about this. We could write a fraction. We could say, this many dentists, 3,714, out of 4,952 dentists recommended that they should have people chew our gum. Now, here's the thing. Look at this fraction. If we write this advertisement like this, do you think that consumers are going to like this very much? And the answer you're probably coming up with is no. And I would ask you, why would you think that consumers wouldn't be very attracted to this? Because they're such large numbers. Okay, so you might say, well, hey, these are both even, and in even digits. Perhaps we could reduce this fraction. Okay, cheating a little bit here, I'm going to pull out my calculator and I say, okay, well, just because they're both even, let's divide these both in half. I say half of 3714, divide that by 2. Here's what we can determine. That's 1857. Already noticing that there might be trouble with this one. It ends in 7. And I say trouble because it won't be even. I think this one, if we split it in half, might be even, but it won't matter. So we divide that by 2, and 2476. Okay, I notice that these aren't both even. They may actually share another common factor, but I'd actually defy you to think of a factor that they have in common. I'm having a very hard time doing so. I'm not going to have an easy time coming up with a factor tree for either of these numbers. Maybe this one because it was even. I'll tell you this, though. Looking at a fraction, it probably would be extremely effective if we could simplify it down to small enough terms, because consumers like smaller numbers. Okay, well, fraction, not a bad thing to write into our advertisement, but probably not very effective. Okay, so maybe we say fractions out of the question here. Now, I'm looking at the ones that are left here. We could write a ratio, but what do we know about ratios? How do you generally write them? You can write this to this colon this, or typically in our class we write them as fractions. Well, we've just sort of done that. If we write this as a ratio, all we're going to be doing is stacking these numbers side by side. Okay? Or we could even write the ratio of those who preferred it to those who did not prefer it. But, simplifying this, chances are, and I'm just spitballing here, that we won't be able to get it down to very, very small terms in order to say, 4 to 1. 4 dentists recommended it to everyone that didn't. That's just me guessing on it. What I'm tipping towards right now are one of two comparisons that we could use. Either a percent or a scale factor. Now, a scale factor of what to what? Remember, we're trying to sell the audience on buying our gum. We want to show that more dentists recommended than those that did not. Okay, so what we could do is we could actually tell the audience how many times bigger the group of recommendations were than non-recommendations. Oh, okay, so here's my question. If we're going to use a scale factor, I want to know how many times bigger this is than this. In other words, what can we take 1,238 times in order to get 3,714? Of course, we've been through this 5 million times. I'm exaggerating a little, and I know you don't know the scale factor off the top of your head, but I do know this. You know how to work backwards. In this instance, we would work backwards. We might say 3,714 divided by 1,238. Neat thing is, and I'm not going to do that for you, you can do it on your own, but this is going to tell us the scale factor. At this point, we would have enough evidence to say, you know what I found out? I found out that this many times more dentists recommended our gum than did not recommend it. And that can be a very powerful statement. The odd thing about this one as well, though, is this. It doesn't give you any scale, it doesn't give you any scope of how many people you asked. 3 times as much as how many total. If I asked 4 people, okay, well, then 3 said I recommend it and 1 did not. That would be a good ratio, but here's what I'm saying. You have no clue how many people I asked. What it's starting to look like is that the best possible, probably, advertisement that we could use here is not the biggest shock in the world, because how many times you've been out in public and when people advertise their things, they use this type of an advertisement. So what I'd like to do is use a percent. Now, if you remember from problem number 5 that I've also posted on YouTube, that if you're going to use a percentage, generally we say